Hi guys, welcome to RTOP for November. And we are reviewing the March Western Conference. There's a chance that we might get it a week earlier than what was advertised in the journal. Ken Redcap is still working that. Stand by. So don't get your tickets quite yet. And so we're looking at that. And Eastern Conference is still on. We're still planning on doing that with the Radio Jove team. That was the last time, I think, in 2017, the Eastern Conference, having Radio Jove group with them. That'll be really good. We'll have a whole group, a whole new set of papers coming in and meet more people. I don't have anything else. So let's go to Wolfgang. He's our time zone. And thanks, Wolfgang, for coming in on time because I sent the wrong UTC time out.
I didn't actually even notice that. But I was a bit, let's say, worried because you're changing from daylight saving time on a different date than we do in Europe. Actually, there's about I think it's a 2 weeks difference. And since my daughter lives in the US, I really have to keep track of that, how we do things when we are talking on the phone. Anyway, there's not really much new from my side. Maybe only a little bit piece of news, something that we're trying out. We're trying to see whether we can do Polarometry, looking at the polarization of signals. So you may recall that we have a very simple-minded barometer with 3 antennas, which is also featured in that recent SDR journal. And in that article, which Vanessa wrote, we explained that because we're looking at the sun, we're also looking at solar flares. And the idea is that while let's call it the standard solar emission is unpolarized, that during flares, sometimes it's polarized. And that's something that we want to measure. What we have done is we have complemented one of our antennas with 2 pickups. These are 2 linear pickups in a 90 degrees angle. And we're now working on we are ironing out the software to do that, to do the analysis of polarization. So that's just a little bit that we started actually last week. We don't have any results because we are still working on the software. So that's whether something will come out of it, we'll see. No idea yet.
Okay. Anybody got any questions for Wolfgang? Okay. Don, why don't you go over what the Deep Space Exploration Society's new grant is for Venus?
Okay. I'll do what I can. We'll get my halfway thing off here. We've just gotten a grant from ARDC to do a ham amateur radio bounce off of Venus, hopefully next March. I don't know if we can really get it together by March or not, but I hope so. We'll be running at 1.29, 1.26 gigahertz in the ham band and using Joe Taylor's T, probably 65, but I'm not sure which mode it will be, which will get us, the JT65 gets us about anywhere from 20 to 30 dB below noise because of the math involved, which is kind of hairy, but it works. So we'll be running hopefully about 2 kilowatts into the dish at DSES, which if you're interested in it, you can see on the web at dses.science. And I don't know, that's about it. We'll be trying to get to, and you can correct me if I'm wrong about this, but I think it's the Dwindleu telescope. Is that the one that the amateur radio people use?
Yeah,
and
the Dwindleu is doing and stuff. Yes, that's right.
Yeah, and they've already done this bounce and actually seen a pulse back probably 10 years ago or so now. So we should be doing, and also with Martin Flynn at the New Jersey outfit, and try to do a 1.29 gigahertz actual amateur radio contact QSO off of Venus. which will be a first. So it'll be kind of interesting to see if we can really do it. It works out. The path losses and everything have been hammered on, and it's feasible. So we'll be ready to give it a try.
All right. Any other questions for Don?
Yeah, Don, this is Jack. Other than the QS, what are the objectives of that bounce? What's the motivation other than to see that you can do it?
That's
Any
it.
other? That's it, huh? Okay.
That's it. It's to do it. And it's going to be tough enough. It's a couple of minutes, I think, or I've forgotten exactly what the time delay is. But it's a test of when you get down to a 60-foot dish, it's down to how accurate we can actually do the tracking, because don't forget, you got to keep moving the dish along with Venus in the sky. Otherwise you'll miss yourself. So, or you'll miss whoever you're shooting at, because that'll be something to worry about too. Venus is a craggy mess as far as a reflector goes. It's a specular reflector for sure. And so there's probably a pretty good reflection signal loss. I was astounded to find out that to remember, it's kind of dim because I was pretty young at the time, but in the late 50s and into the 60s, the military bounced a signal off of, but they also had, I think it was 2 megawatt pulse that they were using at the time. So they had a few dB on the transmit side that we won't have. But they were happy to show that they could bounce a signal off of Venus. Didn't tell them much, but it was done. And I think that was using the dishes in Owens Valley.
Have you looked at things like the progression of Venus on its orbit around the sun versus the Earth? Look at the delta and the distance between the two.
Yeah, it'll be at opposition, because that's the closest one, right? The real problem is that when it's close in March, it'll be very close to the sun. And we run the risk of actually having the sun in the beam if we're not really careful with the pointing. So it's a tricky business all around. You have to have it close. You have to track it. And it'll be very easy to goof up and get the sun. And that'll mean our feed will get cooked. So we can't have that feed, and probably the LNA for that matter. So it's not going to be easy, but it's doable. It's right on the fringe.
Okay. All right. Thanks, Don. That's going to be fun.
Yep. I think it will be. Yep.
I want everybody introduce you guys to Michael Lewis, who is a science ambassador that I think that he's going to be a great contact to be able to get information out to the different science groups. Michael, you want to introduce yourself and what you do and that kind of stuff? Because I think we want to give some of his groups a grant too.
Okay. Good afternoon. I'm Mike Lewis. I'm in Virginia right now, and I'm a new fast starter ambassador. And one of the things that I do is I have an email list that I send out and plan to put some information from the Sarah website on an email I'm sending out this week. I looked at the SciStarter.org website and I saw where there are 3 radio astronomy projects people can participate in. I also would like to try to do a radio astronomy project with one of the libraries in the SciStarter network of libraries that participate in Science Starter project. My list goes out to the Astronomers Without Borders, a couple of astronomy groups in Virginia, and a few other science people like Bill Nye, Planetary Society, that sort of thing. So I'm running out of breath now. I'm done.
That's great. That's great. Michael's got my email and I got his. If anybody has any ideas, I'm going to hook him up with Tom Crowley for grants. So anybody that from his group wants a grant, then we can go through maybe Michael to get them hooked up. And so it should be fun. Okay. And by the way, we did get contacted from the Smithsonian group who is using the IBT that we sent them. And they even asked good questions about the black body radiation. How does a person putting his hand in front how does the thing actually detect somebody's hand or their body that gets in front of that IBT, which is at 12 gigahertz? And so we got Sue Netherly from Green Bank and Tom Crowley both answered the Smithsonian guys. They've also got a scope in the box. So they're going to start working on that. And we have one of the guys, I forget his name at the moment, but he's helping them directly from our Sarah group to get the scope of the box working for the Smithsonian Museum. And what those guys do is they do demonstrations for the Smithsonian Museum. So they're actually demonstrating this to the people coming in. We're really getting out there. They're advertising Sarah along the way. Hopefully we get some good stuff on this. Last but not least, on sort of announcements, I did get contacted from the ARRL engineering book group, and they are publishing the stuff we sent them earlier this year to be put in the ARRL handbook. So we should see that coming out. Very similar to the antenna book, but we added a bunch of the receivers and the other stuff associated with we didn't emphasize just the antennas. We emphasized sort of the whole system approach in that. We should see that coming out hopefully the end of the year. Okay. Let's go to, Andrew. Getting the overseas guys first.
Hello. How you doing, Rich?
Good.
Yeah. Okay. Okay. So I have done a little presentation, not very long, about 3 slides. So let me just find it. Presentation for Sarah. Here we are. While I'm online, I'm going to just grab the opportunity and just say to Ted, do you fancy staying online at the end of the meeting so we can stay on the Zoom together? Anyway, have a think about it. Let me know. So
sounds great. See you then.
Great. Okay. Here we are. This is me tongue in cheek going to say that I've been testing the upgrade to the scope in the box. It's tongue in cheek because this isn't hardly agreed with Lester. Anyway, so just to, for those people who are new to the group, just to give a little bit of background. Firstly, my name's Andrew Thornett. I'm from the UK, just north of Birmingham in the middle, if anybody knows anything about the UK. And about a couple of months ago, somebody on the SARA sort of mailing list mentioned that they'd seen on eBay these solar cooker dishes, which were 1.5 meters wide, and they're being sold for $50. And wondered whether this would be a good idea for creating a radio dish, obviously a rather large radio dish. There's a lot of excitement, some discussion about it, a general agreement that it would be a good idea. And given that we were looking at hydrogen at 21 centimeters, it didn't even matter if the surface of these dishes was not particularly even, it would still work quite well. There were a couple of us, or are a couple of us, who have actually purchased some of these solar cooker dishes with an attempt to try and see if we can turn them into radio telescopes. It is sold on eBay in the States there for $50 with quite cheap postage. Unfortunately, they're not sold in the UK on the eBay UK site directly. You indirectly can buy them through that site, but it's from the American sellers, and then you're going to pay a bit more in postage to get them over to us. However, I found somebody who was doing a house clearance on eBay and was one of these for sale. So I was able to pick it up for £50 and a bit of postage and did quite well of it. So here's my results. Earlier this week, somebody put on the mailing list again saying, Andrew, how far had you got with this? And I got to admit, not very far, because I'd been extremely busy on other activities over the last few months. So my radio astronomy stuff hasn't gone very far. However, that stimulated me this week to get something ready for tonight. I've been busy with hammer, nails, and screwdriver. And this is what I've come up with. For starters, I hope that you can see the green screen, the same solar cooker dish radio telescope, can you? Do you guys all see that?
Yep.
Brilliant. Next page. Here we are. Here's the solar cooker dish put together. As you can see, what I've done here now is taken my cantenna, which was the previous cantenna I made for detecting hydrogen, which worked. It collected hydrogen on its own, but wasn't very effective on its own or particularly good signals. So I thought I would repurpose it here, pointing in the other direction towards the dish, this time using it to work as the waveguide and aerial to pick up the signal from the dish. Found a method there with some bent bits of metal I found in the local hardware shop as a method of connecting it. And so here we are. So I put together some spray paint, got rid of that mylar film on the top that was reflecting the sun to a nice focus and burning anything in its path. Don't know how good it would have been on a kettle, but it was certainly very good at putting holes in cardboard boxes. So I was rather concerned what it would do to my antenna, or to me when I walked past it, because it seemed to be rather hot on my legs. But the spray paint worked very well. And then I had to make a mount for it. So here's my mount, similar design to what I used for my ptarmigan array. You can see here the lots of banging saws and screwdrivers and not very much precision. That doesn't really matter too much. So the basic idea is those bits of wood on the side with the holes, you can vary the angle there on the sort of upper wooden frame against the bottom lower wooden frame, so that you can angle the elevation. And the idea is that this will be pointed just in one single azimuth, and we'll be doing drift scans across the sky. It's a method to collect data. If you're wondering what that shelf is at the back, it's not for storing convenient accessories. It's for putting bricks on to counterbalance the dish at the front. Because I've compared to my ptarmigan array, I've got a couple of issues with this, one of which is counterbalancing this dish. And the second that I'm going to have to deal with is being blown around in the wind and particularly blown over and broken. So I've actually ordered some tent pegs. I'm going to get some guy wires and hold it down to stop from blowing over. So here we are, just as it's put together today, especially for you guys, so that you had something to see. I think it was quite nice, actually. It looks like a serious radio telescope. You've got to have one thing that looks like a proper radio telescope, haven't you? You've got the mount, which is this wooden device. You've got the bricks at the back, which are counterbalancing it. A 1.5 meter dish. The plastic box at the box contains the computer and the receiver and stuff. And this is just over the last 24 hours, or at least slightly less than 24 hours. Just first light. That was done with it before it went on the wooden frame. If you're wondering how I said today it was put together, it was sticking virtually straight up. And you can see there it's managed to detect hydrogen, the two peaks at the sides. And then I put on a couple of astronomy groups I put a request for people to come up with some ideas for some names for my new radio telescopes. I present these to you and see whether you either liked any of those in particular or had any better ideas to suggest. So here, what we got so far, you can perhaps suggest to me to some better names, and then I can think about what I'm going to call the thing. That's it. Thanks very much.
Yeah, my vote is the first one. That's great.
Definitely the signal snatcher. It's alliterative.
Okay. And you can come up with any new names if you want and put them on the SARA mailing list for me. That would be fine.
I like the third one too, TSS.
TSS. Oh, I see. Signal snatcher. Yeah. Okay. Yeah. Okay. Yeah. It's quite a nice one. Yeah, I agree. I quite like Celestial Snooper as well.
Okay.
Okay. Thank you very much.
Great job. Yay. Okay. Let's go to Dmitri.
I do all glad to see you today. I have some message about W51 star creation region. Just a moment, I will share the presentation. Do you see the screen, this presentation?
Yes, yeah, looks good.
Oh, okay.
This is about observations of methanol masers, 6.7 gigahertz frame, 51 star forming region. It's about the source, this is negative test star factory in the galaxy, coordinates specified by methanol radiation of this region from a picture taken from NASA. This region is characterized by high infrared luminosity in one of the largest in the galaxy and works as a tracer of process there. About excitation of this maser and pumping. This is type 2 maser pumped by infrared radiation. Left is additional pictures of W51 region and spots of far infrared and short millimeter wave radiation in the location of this maser spots, which excitate this maser. Some data from Japanese database, symbol is 32 meters, spectrum is shown a peak of radiation more than 600 Yansky, and several features, and there are several features up to 20 Yansky forming pedestal for this line of the maser of this maser. This maser is relatively stable and deviations up to 200 Yansky, as you can see. The instrumentation is the same for this year 2.4 meter dish designed by Radio Risky 3 Bravo Papa for millimeter waves and used by me 0.7 gigahertz observation minimal detectable flux density. This observations 18 Yansky, 1 hour of integration. And the results for me for this maser in this week, it was yesterday, we also obtained my levels up to 500 Yansky and some variations I see some variations in the period of 2 days for this maser, possibly levels maybe in comparison to Japanese, but as I can see, it's systematic. And 1 year ago, my levels was lower than the Japanese. I don't know. I don't know why. Just second, my second dish, and nevertheless, my levels somewhat lower than Japanese data. That's all for today. If some questions, I will get to answer.
Any
Hey,
questions for Dmitri?
Yeah, I got a question. You mentioned that it's a type 2 maser. Can you explain what is a type 2 maser and how it differs from I guess there's a type 1. I'm just curious about the physics.
Just a moment. Type 2 maser is pumped and excitated only by infrared radiations. And type 1 masers excitated by collisions in the clouds. I think by collisions with hydrogen, with temperatures of 100 Kelvin, about 100 Kelvin. Methanol is a tracer of star forming, namely of type 2 maser, because very high infrared radiation in star forming region, and type 2 maser is a good tracer for star forming. It's okay?
Yeah, thank you. That helps.
Anybody else got any questions for Dmitri?
Yes, I do. Do you feel like that maybe the difference in your readings could be related to the time? Like the Japanese maybe took their data some time ago and yours is more current, so there's a variation in the intensity from the maser? Last data from Japan, last data is the March of this year, and I compare my data with March Japanese data, but this measure is pretty reliable with minimal deviations by Japanese data from 600 to 600 to 800 Yansky, but my levels is somewhat lower. I don't know why. This is already my second dish, and my estimations of telescopic characteristic was made for second dish, and nevertheless my levels is somewhat low. I don't know why. I can explain why. I don't say that this is problem from Japanese side, but I checked my setup very carefully, and I don't see why is it different.
Okay. All right. Once again, thanks, Dmitri. Another major. Oh wait, Dennis.
One question. Sir, I was curious to know what your how your tracking mechanism works to get a 1 hour integration. Were you tracking the signal?
Tracking the signal all the time. This was controlled by F1 French F1 HM software by known coordinates. This work with right accession declination coordinates, and this straight all the integration time was. And in 1 year ago, I performed observations with 2 and 3 hours. It's no problem with tracing of the disk. It's okay.
Thank you.
Thanks, Dmitri. Good work. Edward.
Hello. Yeah, so I don't have really anything to show today. Yeah, I'm just working on some improvements on my old 3-meter dish. So this was a wooden dish that I built 6 years ago at this point. And yeah, there are some things that need fixing. So I'll be working on that. So mainly the surface of the mesh has been deformed a little bit over the years. And this has degraded the efficiency. And what's another issue that I'm looking into is this is like an unusual dish because it consists of 8 parabolic segments that can be put together to form a parabola. And I think there's some issue with, I have some overlap in the mesh between each of the segments, but maybe there's some issue that they are not connecting properly. I don't know if this is a problem, but I noticed that the overlap is like curling upward and not touching the mesh of the next segment. Not sure if this is a problem or not, but yeah, hopefully I will figure out.
Okay, any questions? All right, great. Let's see. Jason.
I don't have any observations to talk about today, but I did want to just give you guys a little bit of a quick summary of my trip to the VLA last weekend. As you may or may not have heard, I went out to the NRAO site in Socorro, New Mexico to actually do a site visit for a possible job. It's looking pretty good. I got to see a complete block diagram of the entire system. Basically, the sky was on the left and the hard drives with the data were on the right. Got to see everything in between. It was pretty neat. Yeah, I got there. I arrived on Sunday afternoon in Socorro about 1:30 in the afternoon, and nothing's open in Socorro on Sunday afternoon. There was one restaurant, so I was able to get some lunch, and then it was too early to check into my hotel, so I drove around, scoped out, tried to see where the NRAO operations center was, so I know where to go the next day. And right across the parking lot was the auditorium and convention center for New Mexico Tech. And so I wandered over there just to see it. And lo and behold, there was a poster on the door that said they were doing a joint community theater and NMT production of Macbeth, and it had started 5 minutes before that. So I went upstairs, paid my $20 for a ticket, and I only missed the first 10 minutes or so. And then I found out the next day during my interview that the two leading cast members, both Lady Macbeth and Macbeth, were PhD astronomers working at the VLA, which was pretty funny. And they even had a warning that if you sit in the front row, you'll get splattered with blood. But no, it was a really good trip. I enjoyed it. Had a little bit of a bump in the road in that I forgot to pre-medicate myself for the altitude, and I did end up getting some altitude sickness on the drive out to the VLA site. But nevertheless, it was a very enjoyable, informative trip, and hopefully I'll hear back within a week or so about the job itself, which that would be amazing if I could work out there. But that's all I got for today. I have some photos, but I didn't get them uploaded in time. I guess we'll wait till next time to show you guys those.
Great. Good luck to you.
Thank you.
All right. Jerry Taylor.
Yeah, hopefully. How's the sound? I was having some issues with sound. Am I coming through okay?
Sound great.
Okay, good. I'd like to do a little screen share here. I've been spending the last couple of weeks working with the new software that Jameson and Alex have been working on, the H-Line 3D, and I've found it extremely helpful. It's a good news and bad news. I found that the data, I assume you can see the graph there. That's the raw data that came from the plate Yagi I've got. I didn't realize I had so much of a problem with the with RFI, and it's thanks to Alex and also to Edward for helping me out to try and resolve what was going on. I thought at first it was some sort of a temperature drift or something that was causing that sloped graph, but I guess it come after talking with Edward a little bit. It looks like it's probably RFI that's causing this goofy layered response that I'm getting. But this is the raw data that I got from after processing with the H-Line 3D. And I have one other one to show. And once it's processed, it helps, but I still got that, I got that slope in there. And if anybody has any suggestions, I guess as a little bit of a background, I have probably the world's worst radio telescope location. I'm in a city-sized lot. I got houses all around me, surrounded by trees. So I may just have to live with this. But if anybody has any suggestions on how I might improve that signal, that would be appreciated.
I find I have slope on mine, especially if I'm doing the extragalactic sources, because I'm looking at a lot smaller ones. So even if the slope is very slight, it's exaggerated. And what I find is I actually have to use usually I use a second order polynomial fit to smooth that background. So I'll find a curve that fits that slope from the background, and I'll artificially I'll subtract that curve from the data set, and then it flattens it out. Now I'm doing all of that in Excel, but it would be pretty straightforward to add that feature to the software, I think. If you're interested in talking about that more, we could find a way to connect offline, and I could show you what I'm doing. But actually I recorded I think a week at the Drake's Lounge a couple weeks ago. I recorded afterwards, or no, maybe it was anyway. I got on and did a Zoom recording where I did a share screen, and I went through a step-by-step tutorial on how I do my data processing in the Excel template. And there is a portion at that where I show how I do the polynomial fit to flatten it. You might check that out as well.
Yeah, I remember seeing the video. Yeah.
Is that slope just due to your filter somehow? It's a slope in frequency. It's got to do with it's not amplitude, it's frequency. It's got something to do with your filter, with your system. In which case, if you just take a background, it'll show up in the background. You can just subtract it.
Okay, if I understand it, after doing the calibration, it's and I also did a temperature stabilization test on it, and I let it run for a couple hours, and the LNA, I had it let it acclimate for 20, 30 minutes, and I had the cooling on the SDR, and had a 50 ohm load put on it, and it was flat, like 0.02 dB was the only drift that I had over a couple of hours. It's, of course, when I get the antenna up and start doing the scans, when this craziness happens, and that layering, Edward had thought maybe could be some kind of a reflection or something that could be causing that layering, but all the spikes and valleys I can see as what I think of as RFI, but that layering effect from the raw data is just
there's maybe something coming in on a side lobe. If you look at the peaks, they're regular.
Yeah.
But look on the lower right-hand side there, look how regular those peaks are in frequency.
Yeah.
There's if it's a frequency, it's a frequency deviation, it's not amplitude determined so much as it is got something to do with some kind of frequency problem. In my estimation, you can see the same thing happening on the right-hand side, or my right-hand side of this.
Yeah.
I do find that my SDR still, even with temperature stabilization, the background does drift level-wise and slope-wise. And the way some people actually deal with that is they just recalibrate often, which, because the system just tends to drift, especially.
Sure.
But at the end of the day, there's ways around it too. Like in my case, I can't recalibrate if I'm doing drift scanning and I'm doing a long exposure. I could if I interrupted it, but the way my system is now, I found that I could just get around it by just doing an artificial correction afterwards, because I knew the background had been flattened. And in my case, I'm calibrating against a nearby section of sky so that I can suppress the Milky Way from my data, because I'm looking at other galaxies. So I'm trying to knock the Milky Way signal out. But yeah, it can be removed after the fact if you can do a curve fit, because you can see where your data is, where your actual hydrogen peak is, and then you can tell where the background is. So then it's a matter of just choosing a couple of good sections of that background and coming up with either a second order, or sometimes it's flat enough you can just do a linear fit and correct it.
That's pretty much exactly what Gary and I actually did with this data. So he sent me a whole bunch of data files to one of his runs, and I indeed tried to fit just a line through parts of the background just below and above the hydrogen line of frequency, and it worked really well actually to flatten out the slope.
Yeah, did you, the process at Edward, one thing I wanted to ask you was, you did it just as you described in the email you sent me. You basically took out the hydrogen data and did a linear fit on the background. Is that correct?
Yeah, so the exact thing I think I did is that I just took the parts of the spectrum that are just above and below the hydrogen line. And I also, what you can also see is that at the very edges of the spectrum, you have to let the curve slope down very steeply, as at the other end of the spectrum that happens as well. So I left those out as well. I just took the more or less like linear flat parts of the background between, I don't know, something like 1419.5, 1420 megahertz, and then 1421 to 1421.5 megahertz. And that's where it fits the line through.
Okay.
Otherwise, if you fit like just the line through the entire spectrum, then of course, like you are also like taking the hydrogen line and all the weird slope effects at the very edges into the pit with little creep.
Yeah,
Yeah,
what he's describing is how I do mine as well. Yeah,
okay, I'll have to revisit that. Anyway, I didn't want to take up too much more of your time, but using that H-line 3D that's been a good news, bad news. I love the 3D because you can spin. Now I can see the relationship between the right ascension and the frequency and the amplitude. So when you rotate that cube around, you can see that relationship a lot better than just with the graph. Again, thanks, Edward, and Alex, if you're here too. I appreciate all the help that I've gotten.
One other comment I'd like to make or ask about it. It looks like to me your gain is increasing as you go up in frequency because you have greater peak to peak deltas and noise down there.
Yeah.
I want to subtract out some gain as you get up in frequency.
Yeah, I have no answers other than I have a lousy location. Astronomy.
it would be interesting to look and see if that RFI that you're seeing, the regular peaks across the band, that it's possible that could be coming from your own equipment. I had an issue with that early on where I was actually getting RFI from my own digital feed, the digital part of the feed. And once I ended up getting a long cable and leaving only the LNA on my feed and then running a cable into the house through the window and having my computer and my SDR and everything inside the house. And that really helped my self interference go away.
Yeah, I tried a really fine aluminum mesh screen that I use as a shield over my computer. That didn't make any difference. And I went outside thinking if I get a little bit further away, that didn't do anything either. I guess I'll chalk it up to a lousy environment for doing radio astronomy.
I use a Raspberry Pi type single board computer for my SDR, and I have seen that kind of toothy, where you have a repeatable tooth pattern in your frequency response like that, depending on how close my SDR is to my Raspberry Pi. I found it actually better to move the SDR closer to the Raspberry Pi and use a long USB cable to your computer. That way you keep your antenna, receiver, all that stuff away from your computer.
Okay. Thanks, Jerry. Keep plugging.
All right.
Got a lot of people interested in your project.
Thanks.
And let me introduce you guys to, is it Leif?
Leif like safe.
And the nice thing is that he's the other nuke submariner at Sarah now. I've been waiting for someone else to join, and he went my path. I went from nuke submarining to spacecraft, and he went from that to radar and at Raytheon. And now you're at MathWorks, so he's a MATLAB guy at MathWorks who builds MATLAB. So here's a chance to grab him and figure out all the MATLAB stuff. What do you got going on? Tell us a little bit more about yourself and all the MATLAB stuff.
Sure. So I was double E, and then I did a hitch in the Navy, as Rich says, and worked out in the Pacific for the Navy. And then I switched back to the East Coast, and I've been in tech, either at Raytheon for 18 years, building radars, mostly all over the world. And then about 2 years ago, I switched over to the tool maker, MathWorks, who makes MATLAB and Simulink. So I've been still staying on the aerospace side of the business, but working now for the tool maker as opposed to the tool user. So I'm learning a ton about learning more. It's amazing how much is in MathWorks I didn't know I had when I was over at Raytheon, and I had everything for free. But now, so I've been doing a lot of work with them, given a few seminars online, been getting more and more involved in the antenna and RF space. And I got involved with Sarah about a year and a half ago. And I did my first sort of observation out in Nantucket, an island off of the east coast of the US. I built one of Ted's zip tie antennas, which I had poking out of the back of our house in Nantucket for a week while we were out there. Got a bunch of collections out there, and getting back involved here in the radio stuff. I got a ham license a couple of years ago, just mixing it up. But so I decided I finally should call into the meetings now that I've been watching them on YouTube the past year or so. I was telling Rich that we have a bunch of MathWorks, we have a bunch of seminars we give that are online remote seminars that we can talk about RF tools. And maybe we can talk about setting up a workshop for folks on Sarah. But there's a lot of RF tools that I didn't know existed. And I've been enjoying that space. And my passion project right now is I would like to really try and design an LNA front end, a nice LNA front end that does. I think there's some of the. I think Ted had an example of one that shuts off the amplifier to get the dark sky, or basically for calibration. So I've been working on a paper design right now, but I'd like to basically try and build an LNA that does all the things I want to do. That's sort of automated, that does all of its receiving over the RF line. You don't have to run a second cable out there.
That's just the no-elect LNA. But if you buy the bare bones, you get 4 pins to play with. And if you're short 2 of them, it will give you a resistor instead of a connector. So nothing fancy there. But there's a way to control that, and that's in the PDFs I provide. I had another design where it would, like once an hour, do that for you. And that way you didn't even have to tell it. It would just automatically work it. And it's hard to analyze, but I made some progress. So there are 2 methods there too.
Great. No, I've been reading a paper on an LNA that's being built for the DSA 2000, which is this big array that's being built out in I think it's in Las Vegas, or near Las Vegas in Nevada. And they have built into their LNA basically a system that looks for a certain tone on the voltage feed and automatically switches in a calibration signal from within the LNA when that tone appears on the bias T voltage. So I was thinking about something like that, where you could basically effectively command the LNA from the receiver end to go through various steps of calibration supporting techniques, whether it's a dead load or a reference noise source or something like that. But the article on this, actually, is one of the members here who built it. I think what's the gentleman's name from Caltech who was on the call last week? Or I can't remember his name now, the professor, but he built the LNA, I think. Yes, that's right. Him. That is a one hell of an LNA. If you look at the paper that he wrote about it, it is pretty wild.
Now, Wolfgang has 2 of those LNAs, and I'm not sure that I've ever heard that capability with this LNA that you put a tone out to it.
That's right. The LNA that Sandy has designed has a integrated noise source. And it is, as like just said, it's activated by a tone that you send over the coax cable in. So actually those are fed over the coax cable, and they have this additional capability to have a tone which then, triggers or turns on the noise source.
So I can comment too on this, that there's 2 things that I think that he did that made his so successful. One of them is a device that he can use for the amplifier.
Yeah.
Coming from a special company, it's very expensive, has a very low noise level, I think it's 3.5 material. And then the second thing is impedance matching, to get all the matching really correct on the input. And if you have things going on like switching and things, you can't upset that. And I think he really did a fine job of figuring all that out. And he says that thing is available. If you want to, probably have to pay quite a bit of money, but get it from his source. It's making it in Arizona somewhere.
I proposed to my colleague on the RF design side that we try and model that in MATLAB as a shipping example. And she said that we don't have models in house for that indium. I think it's indium sulfide is what he's got in that device, the first stage LNA. But it's between that and they got a whole bunch of innovations in that LNA. It's wild. It's got a very low impedance input. I think the overall thing is I think it's a third or a quarter of a dB of noise figure. So it's super, super low.
Now, I think Wolfgang said he put it on his noise meter and couldn't see it at all.
Yeah, that's right. It's a standard noise figure. Sandy has tested the tool that he has sent to us. The noise that was tested in the lab was 8.7 Kelvin ago. Whatever that converts into dB is below 0.1 dB. And what has just been mentioned, I think one of the contributing factors that makes these LNAs so good is also the impedance matching. They have a circuitry actually in front of the first transistor, which does some magic with impedance matching, and that's just a fantastic device.
Now, Wolfgang, do you use it in 2 phases at the same time on the same receiver, or do you are you using on 2 different dishes?
No, it's one dish with the 2 linear polarization.
Okay, that's it. I'm gonna try and build one of the disc Yagis that I think Alex put together for my next trip out to Nantucket in February, and I'm hoping to do some collecting then. But nice to meet you all, and I'll leave it here.
Let me mention too, I would encourage you to keep working on what you're doing, because if you can come up with something that's less expensive that the models could afford and use here, it'd be better.
Yeah, no, I think that would be great to build a really, I'll call it hobbyist grade, high end front end receiver, because the new Alex and the stuff that you get from Amazon, they're mass produced, but they aren't. I don't know if anyone's measured one of those, but I'd be curious to know what the actual noise figure or temperature is for those things. But it'd be
We
go ahead.
measured the Lolek at 0.8 dB noise figure.
0.8. That's actually pretty low though. That's pretty decent. In any case, I think it'd be great to build a really high end, as decently you get, say, I know what the number is, like maybe it's $50, $100, that range, puts it in the hobbyist range where people can buy them and maybe make kits and get a group buy or something like that. But it'd be fun to build a really high end or decently high end LNA that we can all work with.
Okay,
All right.
great. Glad you're here.
Thanks.
Catch up with you.
Yeah.
Okay, thanks. Dennis.
Oh, hi. I have one image.
Your microwave dish seems to have fallen down, though.
No, I haven't put it up yet. That's how far I got. I've got my tripod mounted. I've got my mast secured, and now I was going to try to put this Wi-Fi antenna up on top of that, and it's going to be just laying flat because the view of the galaxy is just straight at the zenith for me. That's what's next. I'm sorry I didn't have it up there. It would look a lot better if it didn't look like it had fallen off.
See, Dennis, I thought you had perhaps the same level of skill when it came to radio astronomy as me when I saw that dish on the floor.
I see.
I thought I wasn't on my own.
Maybe
I'm still on my own.
this way. I was getting RFI from the neighbor's TV set. Okay, guys, I'll figure this out more. Thanks a lot. That's the best I can do. Coming up anyway, I'm going to get that on this afternoon, and then I've got to talk to some more of you guys a little more about software. So thank you very much. I've learned a little more.
Thanks. At least we taught you something today about Zoom.
Just a little bit more. Yep.
Okay.
Next thing to learn is how to share.
Okay. Let's see. Jack.
An interesting situation. The AT&T decided they were going to push fiber optic into my neighborhood, and at last count, they've destroyed a couple of surface-mounted transformers, a gas line, and my internet capability. It took a week, but they got it put back together. So I'm just getting back into the communications between my antenna out in the back and where I have all the computers inside. I finally got my communications back, but that was going without the internet for a week was a form of withdrawal. I've survived it though. As far as activity goes, I'm still working most of the time here, not only with just doing hydrogen observation, but working on the couple of different types of positioning systems between using servo motors and using hybrid stepper motors, closed loop stepper motors. And I've got that pretty well worked out. The glitch is always not so much the mechanical side of it. It's the software for being able to make it act like it's an absolute positioner kind of system and not an incremental, especially in the case of the stepper motors. Not so much in the servo. That's pretty much a absolute sort of thing once you get it set up. But anyway, I'm working on those, and those are fun. The system is far more accurate than I have a need for from a standpoint of a 3-meter dish, but nevertheless it's working well. So just continue on that.
Okay. Let's see. Bob.
Yeah, I've soaked up my time working on software for my Meteor camera capturing. I've got 4 cameras, and I had Ubuntu 20 being used, and I tried to advance up to 22 and 24. And each time they change the Ubuntu, they add a different Python version. So it's tricky to change that software. So I reverted back and got everything working again. Then we had storms blowing here, and it's cloudy all night. You don't see as many meteors, although some break through the clouds. That's been tying me up lately. And that's all I had about the glitch.
Okay, thanks. Bruce just popped in. Bruce, what do you got?
Am I working here?
Yep, I see you.
Okay. Yeah, really haven't been up to much and just got here. Just turned the computer on a couple minutes ago. So anyway, running late today. I really haven't been doing anything other than house repairs and cursing, broken plumbing and other such things. But do want to really hope that other people are doing some interesting observations, live through other people's observations, whatever. Thank you.
Okay, and everybody's now. Bruce is the secretary of the Sarah. Been that for about 3 years now, and treasurer, who's probably the hardest job at Sarah, is the treasurer. Tom, you got any updates or anything you need?
No, nothing astronomical. I'm doing some software work on a package that I last worked on, I think, in 2018, and some stuff has changed and it has to be reopened up. So I'm doing some software work, but it's not astronomical related. It's internet and communications related.
Okay, we'll let you do that. Okay, I think, Ted, you're the last one.
Hi, everybody. It's been warm, so I've been doing outside things. And Bob, I'm getting into global Meteor network as well, so I'm playing with that. But now it's getting cold, so I'm back inside doing software things. I'm the Ezra guy, easy radio astronomy. And as the football games go on, I play with the code. Let's see if I can show you what I'm doing. This will be a live demonstration. It's going to be exciting. Ezra makes lots of plots, like a couple hundred, but I've decided that's not quite enough. I think we're sharing. Yes. Okay. I got to get my cell phone. Okay. So it makes pretty plots like this. Across the bottom is the number of samples, which of course come along with the sampling times when it was recorded. And then up and down is frequency. And then the color shown on the color bar on the right is the intensity that was received at that frequency. Okay, that's nice. And what we can see over here is a nice bunch of galactic arm going past, and then another galactic arm going past within one 24-hour period. But this is actually 2 dimensions, and then a third dimension because it has color for each dot. But that means it could be presented in Alex's new way. With H-Line 3D, Alex and Jameson have come up with some nice 3D plotting. And so if we take that, I got to get over here. If we take that plot and now show it in 3D, yeah, okay, those 2 red spots are now high bumps. That's nice. This is one of the plots that could turn into a 3D plot neatly. Here's another one that shows, again, lots of dots, and some of those dots, and all the dots have a value, and that can be represented in 3D as well, something like this. This is where I change and now go to a live demonstration. It's going to get exciting. See if my computer melts down. This one. Okay, and then I have to go over to it. All right, so I think you're now seeing it move around. Is that true?
Yep, it's moving.
And so this is the program running on a file that Ezra cranks out. It's just a comma-separated value file of all this data. And so, yeah, now we can have animated 3D, or at least interactive 3D pictures, plots of all kinds of fun things. The last plot had too many dots, and it takes a long time to render, whereas this one has fewer dots, pixels, and I can show you live that it really is 3D. So that's fun. There are many options to play with as well. Okay, let me cross that off and show you a couple more. But I'm up to suggestions. No, I gotta get over here. I need control of it. This. All right, so that was that plot. Here's another plot. Sure enough, a nice big square galactic plot. And if you plot it in 3D, I suppose it kind of comes out with some shapes with some big bumps. That's supposed to be an arch going from left to right. The same plot can also be done in this Mulvida presentation, and it can be plotted in 3D as well. But there's more. I have been trying to plot the galactic arms with that data and having some success. This is NASA's version of the arms from above. And with that data, I can plot out from the sun, in the yellow dot below, at different radius where that power is. And I am so bold as to identify them with names here. Let's take that data and actually in 3D, slide cross sections vertically through all this stuff and start plotting it. From above, this is a similar picture where we see an arm out here in the distance, in blue perhaps, and a brighter one kind of spiraling out here, sometimes red, sometimes bright green. All right, that's from above. If you look from the side, yeah, I guess so. Now we're plotting actually in 4D. Each one of these dots is in 3D space, and then it contains a value of intensity for density of hydrogen. That's on another computer, so I didn't bring that big file over here to give you a live demo, but you can wave it around in the air. It's fun. We can see the strong galactic arm going out this way and another one swinging out this way from the sun where we are way out here at the point. Another plot looking from the sun out into all those angles. And then if we actually got in the plane of the galaxy, this thin horizontal line, with the sun over here on the right, we can see that those arms curve up. And so that's fun. Some of the galaxy is not in the plane of the galaxy, according to the cross sections. And I think that's where I end. I've run out of plots. So I'm exploring this. I keep tweaking Ezra, and every so often I actually post the new improvements. But if you want to come talk to me, I'm quite willing. That's what I have to show. Questions at all?
I don't think that's enough plots, Ted. I think you need some more. Hey, I had an idea. I don't know what you think about it, but is there any way to get the data that we have collected and create a background image in Stellarium? I've played around with Stellarium a little bit, and I've loaded some sky surveys in there, but I just wondered if there's any way that we could get our own data into Stellarium.
Yeah, that's a Stellarium question. So I haven't researched it either. I saw your question as it went past on the reflector, but I don't have an answer.
Okay.
If you had a data format, I'm sure Ezra could push it out. Bob?
I think Alex has done that or talked about that. I think you can download the Stellarium data and then overlay it. You just said.
Then I guess he's your source. Sounds good.
Well, I would also comment that I've done a fair amount of programming and getting things to work out on a display monitor like this, and all these graphics can take a lot of time and effort. And really, you've really done a very nice job here, Ted, and these graphs all look good. We all appreciate your work.
Fun stuff.
Hey, Ted, an interesting science question that you might be able to do from your data, and I'm just checking. Supposedly, every 30 million years or X number of years, we've got an extinction event, and they think that's where we are in the galaxy as the sun goes around the galaxy. Is there any way, if you plot 30 million years ahead in the orbit, that you could figure out where we're at, and maybe you've got something there like a hydrogen cloud or something that's unusual?
An extinction event, like no more dinosaurs or something.
Yeah, that
we travel into a neighborhood that's bad news. Okay.
Yeah, somehow it has a gravitational effect on the Oort cloud objects, and that causes a meteor or a comet to come crash to Earth X number of years later. But they're thinking that every time we go around the Milky Way once, somewhere along the line, we're hitting something that's causing an extinction event 10 million years later because of something happening.
I know the answer, but I'm not allowed to tell you.
Okay,
So,
never mind.
You understand those security missions and things like that.
Well, all right.
That's a different realm, I think, but okay. Good question.
Okay. That was just a question. This is a science question.
I
Okay,
have another question that too that I've wondered about. If maybe there's a software package out there somewhere that shows the Earth going around the sun at any given time. So you would use Keplerian elements to show this, and the sun's rotation. Because you keep seeing these postings, or I do, about the flares that are coming off of the sun. There's been some X-class flares recently, which are the strongest of the flares. And I always want to look at what direction is that flare. They give you the coordinates of the flare on the sun. So if you could locate the sun's rotation, which is 6 or 7 Earth days, I believe, and understand it versus the Earth to see how close we are to having that flare really directed directly at the Earth, which is going to be a bad news if that happens. I'd love to see that kind of thing if y'all have seen a software package that does that.
I've seen plots of that. They're blue with lots of red and green spinning out from the sun. I'm thinking from space weather, that kind of world. Spaceweather.com.
Okay. Okay. Thanks, Ted. And I think Preston, I missed you. So go ahead.
Okay. I was making another screen when you called on me, trying to copy off the chat messages, but I don't have anything new except I was saying in the chat that I'm interested in the RF modeling seminars, if any of them are put forth for Sarah to receive.
Yeah, I'll talk to Rich offline. Maybe we can talk about setting up some of the modeling seminars using the MathWorks tools. The nice thing about the MathWorks tools now is that we had this thing called MATLAB Online, which is like basically an online version of MATLAB. It's amazingly capable, and you can get a basic account for free. But if we do these seminars, it gets you the full MATLAB Online with every single toolbox that they offer for about a month, and that's a nice back door into the entire MATLAB suite that is pretty much out of reach for most hobbyists. I think there's probably a hobbyist level, but some of the toolboxes are really pricey. But yeah, if we can pull it off, then Rich, I'll set up with you. Maybe we can figure out a time to do that.
That sounds great.
Thank you.
And I'll send also a link to, I did an online recording it's focused on a radar design example, but I'll send a link to that if folks want it. It's available through our website, so I'll send that to Rich. I don't know I don't know, where do these things come out, Rich? Is it just in the Sarah group chat, or is it in the journal? How does it?
My recommendation is if you could put it on now, that'll get recorded. And if you look at the YouTube video, it's under the description. I put all the links in the chat under the description. Okay. And if it's not in the YouTube, then I recommend putting it on the listserv, just showing it on the listserv so people can find it there.
Okay. I'll try and, I have my work computer up right here across the room. I'll try and figure out what the link is, and I don't know how long you guys stay on afterwards. I'll either push it here or I'll push it to the listserv. But
I'll send it to me and I'll put it in after the fact.
Okay. All right.
Probably a good way to do it. All right.
All right. Thanks.
Great.
Thank you.
Did I miss anybody?
No, but Rich,
all right. Excellent.
Sorry, Rich, is that Andrew here? Something I forgot to mention when I was giving my bit. Can I mention it now?
Go ahead.
Yep. Had a little baby arrive recently, not literally a baby, a bit of an RF one. Again, some time ago, there was a bit of discussion about cavity filters. And it turns out there's this firm in China through AliExpress that you can actually buy cavity filters through. I actually got one. I don't know if it's going to make an iota of a difference to the quality of my Radio Astronomy, but hey, it was a nice thing to get. Here's their picture of their cavity filter with a 1, 2, 3, 4, 5, 6, 7 by the looks of it. Screws on it. I'll put the link in the chat, but on my website's there at the top. But that's got all the filter specifications if you're interested. It's 1,420 to 1,427. And I've got their pictures of the specification sheets and how that actually works out in practice in terms of what it does with the signal. Anybody's interested. And a little bit of a first light using it. So as you can see from this picture, I'm pretty sure the one on the right is pre-cavity filter and the one on the left is post-cavity filter. I think that's right. It looks like it's lowered the noise floor a little bit. And the second image down here was a day later, which again is a little bit lower. This is it hasn't been used for very long, but just if you're interested. So I'll put that link into the chat.
What was the cost?
About £150.
So that's about 50 cents in US. Is that what I understand?
Something like that. Something like that.
Yeah. Okay. Just checking.
Which bit's the chat? Oh, chat. Here's chat.
All right. All right. Yeah. Anything else? All right. Thanks, everybody.